Hello. As promised, I'm going to do even more factoring. As a matter of fact, at this point, I'd say we're up to a plethora of factoring. Now, you might not know what the word plethora means. Well, one of the meanings of the word plethora is a whole lot of. We're up to a whole lot of factoring. But there's actually kind of a negative connotation to the word plethora in some people's minds. Sometimes a plethora can be interpreted as meaning an excess. And let me explain to you in what context I mean we may be doing an excess of factoring. In any sort of mathematical learning, the key part of the learning process is practicing. I don't think there's any branch of mathematics where that is more true than factoring. You could watch us factor for a week of Sundays, and until you sit down with pen and paper, you're not going to develop any skills. It's kind of like learning to drive. You watch your parents drive your whole life, but the first time you get behind the wheel, at least if you're like me, you have no idea what you're doing. In this part of the lesson, I am not going to introduce any new techniques of factoring. So a really good thing to do with this part of the lesson, if you're watching on tape, is to use it as a review part of the lesson. Go ahead and work your practice homework now. Then come back and watch this part of the lesson, and every example that comes up, freeze the tape and you work it yourself. That way, if you get stuck, you can listen to me talk it through. And even if you don't get stuck, you can feel really good when you listen to me talk it through that you figured it out all by yourself. So let's get going. Onward with our plethora of factoring. Let's factor 12x squared minus 16x minus 3. You remember what the first step of factoring always is? You need to factor out your common factors. There are no common factors here. So now I need to make a choice. Do I want to factor by guess and check, or do I want to factor using the grouping method? When I have trinomials and the leading coefficient isn't 1, I don't spend too much time contemplating guess and check. If both the leading coefficient and the constant are prime and positive, I might try guess and check, but otherwise, I don't want to spin my wheels for a long time. I just go ahead and use factoring by grouping. So let's factor by grouping. What am I looking for? I'm looking for a pair of integers that multiply to negative 36, that's 12 times negative 3, and add to negative 16. I want a pair of integers that multiply to negative 36 and add to negative 16. Since the product is negative, one of the numbers is going to have to be positive, and one of the numbers is going to have to be negative. And since they're going to add to negative 16, these two numbers are going to have to be pretty far apart, because when you add a positive and negative number, ultimately you have to perform some sort of subtraction. And if I'm performing subtraction and getting 16, the two numbers need to be pretty far apart. So I'm thinking to myself, can I think of two numbers that are pretty far apart that multiply to 36? Well, a couple candidates come to mind. 1 and 36, 2 and 18. Do either one of those pairs have a difference of 16? You betcha. 2 and 18 do. So let's see. I want one of the numbers negative and one of the numbers positive, and I want the sum to be negative 16. That would be 2 and negative 18. So that's the coefficients I want to use when I split up my linear term. 12x squared minus 16x minus 3. I'm going to go ahead and take that negative 16 and split it up into plus 2, so I've got plus 2x, and minus 18. So I have minus 18x. And of course I have my constant term. And it's always a good idea to check as you go along. And if I simplify 12x squared plus 2x minus 18x minus 3, I do indeed get the original trinomial. Let's go ahead and do our factor by grouping. 12x squared and 2x. What kind of factors do they have in common? Well, 2 goes evenly into both 2 and 12, and then we also have a common factor of x. And when I factor 2x out, what do I leave behind? I leave behind 6x from the first term, and I need to leave behind a placeholder of 1 so that when I distribute 2x through the parentheses, I do indeed get my plus 2x factor. Now let's look at my second two terms. I want to factor my second two terms in a very deliberate way. I want to factor it so that I leave behind the binomial 6x plus 1. What do I need to factor from minus 18x minus 3 so that I leave behind 6x plus 1? I need to factor minus 3. Now let's look at this. 2x times 6x is 12x squared. 2x times 1 is plus 2x. Minus 3 times 6x is minus 18x. And minus 3 times plus 1 is minus 3. I'm good to go. Now I can pull out my common factor, which is 6x plus 1 times 2x minus 3. Alrighty, I'm going to leave this for you to check. As a matter of fact, I think I'm going to leave all my examples today for you to check because it's good practice for you to go ahead and FOIL out your checks. Let's factor 12x squared minus 16xy minus 3y squared. This looks almost identical to our last example. The only difference is I've now introduced a second variable. I've introduced a y. But let's go ahead and try the same process. I'm going to take 12x squared minus 16xy minus 3y squared. I'm still looking for two numbers that multiply to negative 36 and add to negative 16. And guess what? 2 and negative 18 will still work. The difference is, this time, instead of splitting up the term minus 16x, I'm splitting up the term minus 16xy. So I want to split that up into plus 2xy minus 18xy. And I still have my minus 3y squared. Let's factor by grouping. In the first two terms, I have a common factor of 2, and I have a common factor of x. And that leaves behind 6x plus y. Now I want to factor my second two terms in such a way that I also leave behind the binomial 6x plus y. Well, what would I need to factor out to leave behind 6x plus y? Well, let's first consider our coefficients. What do I need to multiply 6 by to get negative 18? Negative 3. But notice that both of the second two terms in my 4-term expression have a factor of y as well. So I need to factor out a y as well. Let's multiply out and make sure that I didn't make any mistakes. 2x times 6x is 12x squared. 2x times y is plus 2xy. Minus 3y times 6x is negative 18xy. And minus 3y times y is minus 3y squared. I have factored correctly. Now I have two terms, each of which has a binomial factor of 6x plus y. Let's take out the binomial factor of 6x plus y. When I do that, I leave behind factors of 2 and x from the first term, and I leave behind factors of minus 3 and y from the second term. And as I indicated in the last problem, I'm going to let you do your own check because it's good practice for you. For 15a squared plus 4ab minus 4b squared. Have you tried this one? Let's see what happens. What we're looking for is two numbers that multiply to the product of 15 and negative 4, which is negative 60, and add to 4. We want a product of negative 60, and we want a sum of positive 4. Well, in our product, we're getting a negative result. So the two numbers need to have opposite signs. I need to think of a positive and a negative number that multiply to negative 60 and add to 4. Well, let's think about our times tables. What are some things that multiply to 60? 5 and 12 do, but 5 and 12 have a difference of 7. 6 and 10 do. Hey, guess what? 6 and 10 have a difference of 4. So if I think of negative 60 as 10 times negative 6, the sum of those two numbers is indeed positive 4. That's the ticket. I'm going to take my 15a squared plus 4ab minus 4b squared, and I'm going to rewrite that middle term as the sum of 10ab and negative 6ab. I can write those two terms in any order. I think I'll go ahead and use the order that I just expressed. And then I also have my minus 4b squared term. Looking at the first two terms, I have a common factor of 5, and I have a common factor of a. So when I factor out 5a, what do I leave behind? I leave behind a 3 and an a in my first term, and I leave behind a 2 and a b in my second term. Now I want to factor the second pair of terms in such a way that I also leave behind 3a plus 2b. Well, let's focus on negative 6ab. What do I need to multiply 3a by to get negative 6ab? Well, I need to introduce a factor of negative 2, and I need to introduce a factor of b. Now, let's just not assume that this works. Let's check. 5a times 3a is 15a squared. 5a times 2b is plus 10ab. Minus 2b times 3a is minus 6ab. And minus 2b times plus 2b is minus 4b squared. I was successful. I also have a common binomial factor to my two terms, 3a plus 2b, and when I factor that out, I leave behind 5a minus 2b. Were you able to do that by yourself? If you were, great. If you weren't, that's okay. Why don't you freeze the tape and go and work this problem by yourself to kind of bone up your skills before you work the next example. 4x squared y squared minus 10xy squared minus 14y squared. Were you successful in factoring this one? Maybe if you weren't, one of the things that you forgot is that the first step in any factoring problem is to look for and factor out common factors. And in this problem, all three terms have factors of y squared. So the first step in this problem is to factor out the common factor of y squared. I also need to look at the coefficients. 4, 10, 14, those numbers all have a factor of 2. So from my coefficients of 4, negative 10, and negative 14, I can factor out a 2. So we've got 4x squared y squared minus 10xy squared minus 14y squared. And the first thing we're going to do is we're going to factor out 2y squared. That leaves behind 2x squared minus 5x minus 7. Now let's look backwards to make sure we didn't make any boo-boos. 2y squared times 2x squared, that's 4x squared y squared. 2y squared times minus 5x, that gives me a coefficient of negative 10, an x and a y squared. 2y squared times negative 7 is indeed negative 14y squared. Now, if you did get stuck when you tried working this one by yourself, why don't you stop the tape for a second and see if you can figure out how that residual trinomial, the trinomial that we got after we factored 2y squared, see if you can figure out how that factors. Alrighty, we need to factor 2x squared minus 5x minus 7. I could factor by grouping, or I could factor by guess and check. The reason why I'm even thinking about guess and check this time is because both the coefficient on x squared, which is 2, and the constant, which has something to do with 7, look like prime numbers. However, the fact that the constant is negative, that doubles the number of possibilities, and I don't really want to spend that much time guessing and checking. So I think I'm going to go ahead and use factoring by grouping. I'm going to move my equal sign a little bit to the left so that I have some room. I still have my factor of 2y squared. I need to find a pair of numbers that multiply to 2 times negative 7, which is negative 14, and add to negative 5. When I think of 14 and I think about numbers that multiply to 14, the first thing that jumps to my head is 2 and 7. The first thing that might have jumped to your head is 1 and 14, but I'm pretty sure 2 and 7 would jump to your head eventually. And sure enough, 2 and 7 have a difference of 5. Is there a way I can make 2 and 7, one of the numbers positive and one of the numbers negative, so that they add up to negative 5? Oh yeah, there is. I can make the 2 positive and the 7 negative. So let's do that. Let's rewrite minus 5x as plus 2x minus 7x. Now let's do our factoring by grouping step. 2x squared and 2x both are evenly divisible by 2x. When I factor that out, I leave behind an x from the first term, and I need to leave behind a factor of 1 from the second term so that when I distribute the 2x through these parentheses, I do actually get the plus 2x term. So I want to factor now negative 7x minus 7 in such a way that I again leave behind x plus 1. Well, what would I have to factor out? That would be negative 7. So let's see what we have. I still have my common factors of 2y squared. Now, what do I get when I pull out my common factor of x plus 1? Well, when I pull out my common factor of x plus 1, I leave behind a factor of 2x minus 7. Now again, I think it's a really good idea for you to check this yourself because that'll give you good practice on multiplying polynomials. Let's factor 30 plus x minus x squared. Now I'm going to show you a couple ways of doing this. Sometimes when I find a trinomial like this, I start thinking sort of like this. I focus on the x squared first. You might be wondering, why is the x squared term written at the end? It's just the case that very, very frequently when math people are writing down trinomials and there's a negative coefficient on x squared and the constant is positive, they'll write the constant term first and the squared term last. Focusing on that minus x squared, the only way I'm going to be able to multiply my lasts together using integer coefficients and come up with negative x squared is if one of my binomials ends with plus x and my other binomial ends with minus x. Now I need to think of some numbers that multiply to 30. 1 and 30, 2 and 15, 5 and 6. Which one of those pairs do you think works? Well, since I have a plus x and a minus x, I think I'm looking for something that has a difference of 1. And 6 and 5 have a difference of 1. Now the question is, which one of these factors gets the 6 and which one of these factors gets the 5? Well, golly, I want to end up with plus x, so the plus x needs to be multiplied by 6 and the minus x needs to be multiplied by 5, which means the 6 needs to be in the not plus x factor and the 5 needs to be in the not minus x factor. Now, I don't know about you, but just explaining that made my head twist around about 3 times. So let's see if we could come up with a different strategy. I think maybe a little safer strategy would be to just go ahead and use factoring by grouping. So let's try that strategy. What I'm going to do is I'm going to look at my squared coefficient, which is negative 1, and my constant, which is 30, and determine that their product is negative 30. So what I need to do is find two integers that have a product of negative 30, and then my linear coefficient is 1, so I want to have a sum of 1. Well, I just told you what the pair of numbers are. The pair is 6 and negative 5. Okay, so let's go ahead and rewrite our trinomial, splitting our linear term up into 6x and 5x. Remember, I can do that split in any order that I like. So I think I'm going to write on a whim the minus 5x first and then write the 6x. So let's look for common factors in the first two terms. Well, in the first two terms, 5 divides evenly into both coefficients, so I can factor out 5, and that leaves behind 6 minus x. So now I want to factor my second two terms in such a way that I still leave behind 6 minus x. Well, focusing on the 6x, if I pull out an x, then when I distribute x through 6 minus x, I will indeed get 6x minus x squared. So let's go ahead and factor out our common binomial factor of 6 minus x. Well, hold on a second. I think I made a mistake. Because if I look at the line above, what I have is the product of 4 factors. I'm not supposed to have the product of 4 factors. I'm supposed to have two terms, each of which has one monomial factor and one binomial factor. When I factored this x out from the second two terms, I needed to remind myself that I was adding x times 6 minus x to 5 times 6 minus x. Now I can go ahead and pull out my common binomial factor of 6 minus x, and that leaves behind 5 plus x. And this is the factorization that I figured it out earlier, but I don't know about you, but it didn't give me nearly as big a headache figuring it out this way. So let's use this trick again. What am I looking for this time? I'm looking for two integers that multiply to negative 32 and add to negative 4. Did you figure it out? Well, what do I want? I basically want two numbers that multiply to 32 and have a difference of 4. When I see 32, the first thing that pops in my head is 8 and 4. I think it's probably because I've had a whole lot of practice with factoring. I think with enough practice, it'll pop into your head just as quickly. Now, is there some way that I could take 8 and 4, make one of the numbers negative so that the sum was negative 4? Sure, let's make the 8 negative. So I'm going to take my linear term and I'm going to break it up into minus 8a plus 4a. Now let's go ahead and do our factoring by grouping. The first two terms, 8 goes into both 8 and 32 evenly. So I'm going to factor out 8, and that leaves behind 4 minus a. So I want to factor the second two terms in such a way that I also leave behind 4 minus a. Well, focusing on the 4a, what I would need to factor out is a factor of a. Let's check. 8 times 4 is 32. 8 times minus a is minus 8a. a times 4 is plus 4a. a times minus a is minus a squared. I have a common factor of 4 minus a in each of my two terms. When I pull that out, I leave behind an 8 from the first term and a plus a from the second term. And make sure you check that that answer is correct. How about 18 plus 27t minus 5t squared? First thing I'm thinking is, are there any common factors? Well, focusing on that last term, the coefficient is 5, and 5 doesn't go into 18 or 27. At the same time, t is not present in the first term, so there are no common factors. So what do I need to do? I need to come up with two numbers that multiply to the product of 18 and negative 5. Let's see, that product is negative 90. I need to come up with two numbers that multiply to negative 90 and add to positive 27. That sounds kind of tricky to me. This seems like it might be a good place to actually do a little bit of scratch work. So I want a product of negative 90, and I want a sum of positive 27. Since the product's negative, one number's positive, one number's negative. Since the sum is positive, the number with the larger magnitude needs to be the positive number. Well, let's be very methodical about this. 1 times 90. Let's make the negative 1 and the positive 90. This adds to 89. 2 times 45 is 90. Let's make the 2 negative and the 45 positive. Again, since I know the sum is positive, the number with the larger magnitude needs to be the positive number. But this was a no-go because the sum is 43. How about 3 and 30? I want the 30 to be positive and the 3 to be negative, and hallelujah, pretty darn quickly we came up with our pair of numbers. What I want to do is I want to take that 27t and break it up into minus 3t plus 30t. In my first two terms, I have a common factor of 3. Let's factor that out. That leaves behind 6 minus t. In my second two terms, I want to factor in such a way that I leave behind 6 minus t. Focusing on the 30t, what I would need to factor out is plus 5t. Let's make sure we're good to go. 3 times 6 is 18. 3 times minus t is minus 3t. 5t times 6 is plus 30t. 5t times minus t is minus 5t squared. We're good to move forward. Let's factor out 6 minus t. When we do that, we leave behind 3 plus 5t, and make sure you check to see that this is correct. Let's factor 12 plus 8t plus t squared. You know, I'm on a factoring by grouping roll, so I could just go ahead and factor this by grouping. And hopefully you are practicing ahead before watching me, and if you did factor this by grouping, that would be fine. I think I'm going to factor this a different way, because this time my t squared term is positive. So there's really no reason at all to have it written last. I think I'm going to reorder my terms so that t squared is written first. Again, it's all about choices, and this is a choice that I'm making. If you factored it the way it was written, even if you used grouping or guess and check, that's fine. I'm just making this choice because I'm more comfortable when I'm performing guess and check if the squared term is written first. So what am I looking for? I'm looking for two numbers that multiply to 12 and add to 8. I came up with them right away. It's 2 and 6. So how does this factor? It factors into t plus 2 times t plus 6. I think I am going to check this one just to remind you why this sort of guess and check works. When I FOIL this out, t times t gives me t squared. 2 times 6 gives me 12. So that's why I was looking for two numbers that multiply to 12. Look at my O and I. My O is plus 6t, and my I is plus 2t. What's the coefficient? The coefficient is 6 plus 2. I was looking for two numbers that multiply to the constant and add to the coefficient on the linear term. Let's look at this problem. Well, this isn't a trinomial, so I don't think I'm going to use a trinomial factoring strategy. But as with all factoring problems, the first issue is, are there any common factors? And if so, what's the greatest common factor? Well, looking at the terms minus 6t and plus 10t squared, the two terms have a factor of t in common. But these two terms have something else in common as well. Both of the coefficients are even, so they're both evenly divisible by 2. So I can factor 2t. When I do that, I leave behind negative 3 from the first term and plus 5t from the second term. 2t times negative 3 is negative 6t, and 2t times 5t is plus 10t squared. I could stop with my answer written this way, but when we're writing the terms of a polynomial, it's pretty standard procedure to write the terms in descending powers of the variable, with the only exception generally being if the leading coefficient, that's the coefficient on the power of the variable that has the greatest exponent, is negative. Well, the leading coefficient here isn't negative, it's positive 5. So I think a more orthodox way to state this factorization would be 2t times 5t minus 3. Now let me be clear though, if you stopped here, your answer would be 100% correct, especially given the way the problem was stated in the first place. So let's look at x squared plus 81. Did you try factoring this? Did you come up with x plus 9 squared? If you did, you're not right, because remember, x plus 9 quantity squared means x plus 9 times x plus 9, and when you FOIL this out, you do get an x squared and a plus 81, but your O and I, they don't add up to 0, they add up to plus 18x. And we don't want to get x squared plus 18x plus 81, we want to get x squared plus 81. Remember, we talked about in lesson 9 that anytime you have x squared plus a number squared, the binomial is prime. The binomial x squared plus 81 is prime. How about x squared minus 81? This is a difference of squares. And if we remember one of our special products, the product of two conjugates always multiplies to a difference of squares. So this will factor into x plus 9 times x minus 9. Both of those last two examples are special kind of factors, so we're going to talk about that a lot in lesson 11. One last example here. Remember, the first step in factoring is always to look for common factors. There's a common factor between x squared and minus 81x. That's a factor of x. So when I factor out that common factor, I leave behind x minus 81, and since nothing's being squared or cubed or any other kind of exponent other than 1, I'm done factoring. So that ends lesson 10. As I mentioned at the start of my part of the lesson, the main thing you need to do with factoring is practice, practice, practice until you've done a plethora of factoring.